Let's look at this question. It is from 2009. It should be question 2. Let's work on this first part of it, part A of it. Let's use maybe, blue. Okay, so you can pause the video to read the question. We are really familiar with this setup, right? This is our photocell, and we use it to observe the occurrence of photoelectric effect. Now it says, as violet light is shown on the sodium target, electrons have leave the sodium and move to the right, causing a small current in the circuit. When the wavelength of the light is increased, the light becomes red. When the wavelength is increased to the wavelength of red, no electrons leave the sodium. Explain why violet light but not red light causes the electron emission. Yeah, let's analyze it a little bit. When you increase the wavelength here, you are actually wavelength increase, meaning you are decreasing the frequency. Now, if the frequency is decreased, then your photon energy, which is equal to h times f, is going to be decreased. So that's your HF minus phi, work function of the metal, the sodium target here, is less than 0. Now, in order to see this photoelectric effect, we have to make sure that this part is greater than or equal to 0. So it must mean that your violet light, for your violet light, the frequency is good enough. The frequency is good enough to what? Enough of what? Your frequency of violet light is going to be greater than threshold frequency. But your red light, the frequency of your red light is going to be less than your threshold frequency. So that if you use a violet light, you see this. If you use a red light, you don't see the photoelectric effect. All right, now let's put into words here. Yeah, let's use a blanks. Violet light. Why violet light but not red light causes the electron emission? And in order to see the occurrence of PE effect. Now I'm using the short version, so in the test you want to write like a photoelectric effect. The frequency light. No, actually let's use some easy math language here. The F incident must be greater than, actually you can put equal to here, it doesn't affect it too much, okay? F incident, the incident light, the frequency of the incident light should be greater than 0, F0. F0 is the threshold where F0 is the threshold frequency, frequency. So for this one, it must be the case that your frequency of violet light is greater than F0, but your frequency of red light is going to less than threshold frequency F0, so that you cannot see the electron emission when you shine the plate with red light, but you can see it using the violet light. Okay, it's kind of really typical in our photoelectric effect.